Let us try to understand the simplest function first. The input for the function first is grammar symbol. Okay, let us consider alpha as a string of grammar symbols or grammar symbol. Okay, so given input as grammar symbol alpha, the output of the function always would be set of terminals. What is this set of terminals represents means this set of terminals is nothing but set of terminals that may begin in the strings derived from alpha. First of alpha gives set of terminals that begin in the strings derived from alpha. So let us see how do we get this set of terminals from first of alpha. Three simple rules. If you assume alpha to be a terminal, okay, if alpha is a terminal, then first of alpha is that alpha itself. Like first of A is A, first of plus is plus, first of ID is ID, or first of star is star. Simplest rule. If it is a terminal, simply add the terminal into the output stream. Let us see if alpha is a non-terminal. If it is a terminal, simply add the terminal. If it is a non-terminal, if you look at non-terminal, non-terminals can be categorized into two types. One is null productions, other is non-null productions. Okay. If it is a null production, then simply add that epsilon into the first set. Okay. So first of alpha is epsilon. If alpha simply derives to epsilon. If you have a rule something like alpha to epsilon, simply add that epsilon. Or if it is a non-null production, that means you have a rule something like alpha to x1, x2, x3. In that case, first of alpha is first of right hand side. First of alpha is first of x1, x2, x3. And when you have string of symbols, a first function always starts with the first symbol. Okay. So once again, see this rule is recursive. First of alpha is first of this, which automatically implies first of x1. Okay. So if first of x1 ends with set of terminals, okay, if it does not derive to any epsilon, rule ends there itself. Otherwise, if x1 derives to epsilon, that means this is epsilon, so should continue with the next symbol. Then first of alpha is first of x1. Yes, add everything but except epsilon. Because of epsilon, apply the first function, that's why union first of x2, x3. This is where when x1 derives to epsilon. When there is epsilon, don't add epsilon but add all the input strings other than x1 and continue applying first function with the remaining symbols also. That means, for example, first of x2, x3 if you take, how do I evaluate first of x2, x3? As per this rule, it is first of x2. It is first of x2. Once again, if first of x2 ends with set of terminals, ends there itself. If at all x2 derives to epsilon, it is even first of x3. Okay. Don't add epsilon. If it derives to epsilon, don't add epsilon. Add even first of x3. That is the. Let's try to understand this procedure by taking an example. Okay. Let me take the example of the grammar which we have used so far. Okay. That is unambiguous expression grammar that defines all arithmetic expressions with plus and star. Okay. What is that? E2. I'll take directly the the grammar which is free of left recursion. E2 TE dash E dash 2 plus TE dash T2 FT dash T dash 2 star FT dash R epsilon F2 ID R E. This is the grammar. Now let us try to find out what is first of each non-terminal E, E dash, T, T dash and F. Suppose I want to find out first of E. What is first of E? As per rule, if E is a non-terminal, apply the first function on right hand side of the rule. So, first of E is first of TE dash. What is first of TE dash? Start with the first symbol. So first of E is first of T. Okay. So first of E is even first of T. What is first of T? First of T is first of F. First of F is what? Now you are ending with terminal. So it is ID. And if you apply the same rule on the other production, the first symbol is a terminal which is left parenthesis. Hence ID and left parenthesis. I repeat once again. First of E is first of T dash. What is first of T dash? It is first of T. Now take the rule for T. In T, first of T is first of FT dash. So in first of FT dash, how do we evaluate it? The rule is recursive. So every time you have to apply the same rules. Okay. First of FT dash is first of F. What is first of F? First of F is first of ID. Since ID is a terminal, first of any terminal is terminal itself. So add ID. This is what you get if you apply the procedure for the first production. You have one more production here. Apply the rule even for the other production. So first of F is first of the first symbol which is left parenthesis which is a terminal, hence ends with even left parenthesis. Since it is ending with only terminal symbols, hence ends there. Now what is that we can do? First of E, first of T, first of F, all the three are same. So add these symbols even for first of T, first of F. Okay. Now let us see what is first of E dash. Take the rule for E dash and apply the rules. What is the production for E dash? E dash is plus T E dash or epsilon. Let me apply for plus T E dash. First of E dash is first of plus T E dash. And first of plus T E dash is first of plus. Since it is a terminal, now we need not have to go with the next non-terminal. It ends there. The recursive rule is applied until it ends with the terminal symbol. Okay. So first of E dash is now first of plus T E dash which is plus. And there is another rule. Now E dash to E dash is the other rule. So whenever the rule is null production, what it says? When alpha is a non-terminal and has a null production, simply add epsilon to the first set. So because of this null rule, we get even epsilon. So first of E dash is the first terminal symbol plus as well as epsilon, as simple as that. Now if you look at T dash now. T dash, first of T dash is what? Let us straight away apply. First of T dash is first of star of T dash which is star and also epsilon. So star epsilon. What is first of F? Let's see once again. First of F is ID, this one. What is first of T? First of T is first of F. So whatever you have here, same thing will be. This is how we find out the first function. Let us try to understand by taking few more examples. Let us try to understand the function first by taking few more examples. Let's consider this example. Let's start with the first one. What is first of S and A in the first example? What is first of S? Look at this. First of S is first of right hand side, AAD. So first of S is first of A. Okay, there is only one rule and is starting with the terminal, so simply add the terminal. Now coming to first of A. First of A is first of CD. C is the terminal, so ends with only C, the first symbol only. And in the alternative production it is E. So C, E. That's it. Now coming to the second example. Let's take the second example. What is first of A here? First of A is first of B. So first of B is what? A. So A here. And also epsilon. So when you substitute epsilon here, it should continue with the next symbol. When B derives to epsilon, it should not stop with the first symbol. It should continue even with the second symbol. Okay. So it ends with B. Are you able to follow me? If you recollect, A2, x1, x2, x3, when you have something like this, we start with x1. If x1 contains only set of terminals, add it. If it contains epsilon, then continue even with the next symbol, that is first of x2. Similarly, if x2 has some set of terminals, add it. If at all it contains epsilon, continue with this. If x1 derives to epsilon, x2 derives to epsilon, x3 also derives to epsilon, then only you can add epsilon here. Remember that rule. That is what we use here. Okay. So, on applying the rule for the first production BB, we got AB. Now, let us apply on the other side. First of A is first of CD. First of A is first of C. First of C is C here. Now, because of epsilon, once again continue here. Hence, we get D. Since it's all ending with terminals, it's only ABC. That's how it is evaluated. Now, coming to B. What is first of B? First of B, first symbol is A and the other one is an null production. Coming to C, first of first symbol is C and epsilon. That is first. Now let's take third example. Let us find out what is first of S, A, B, C, D in the third example now. First of S is first of A. First of A is A here. Now because of epsilon continues with first of B. What is first of B? First of B is first of C. First of C is B. Okay. And because of epsilon, it continues with D. So look at this. First of A is first of A. Okay. Because of epsilon, it continues with B. Now coming to B, it is C. Here C, for C, since it is B, because of epsilon continues with D and that's it. We need not have to continue further because C ended up only with this terminal symbols. There is no epsilon here. Now coming to, this is a non-terminal. The other side. What is first of C? First of C already evaluated. It is B. Because of epsilon, B is already added. Because of epsilon, it continues with D. And D is nothing, first of D is nothing but E here. Okay. Now, if you look at this epsilon, C derives to epsilon, D also derives to epsilon, hence add epsilon. Now, let us look at first of A. What is first of A? A comma epsilon. Now, what about first of B? Look at this, first of B is first of C. First of C is B. Because of epsilon, ends with B. Now, first of C, B comma epsilon. First of D, E comma epsilon. So here this is most important, first of S. Any confusion? Otherwise I'll repeat this once again. How to get first of S. First of S is first of A. First of A is A here. Because of epsilon, now it continues with B. Okay, now what is first of B? First of B is first of C. Now if you look at first of C, it is B here. Now because of epsilon, it goes back here and ends with this D. And look at this, after this B, it is not continuing with CD. So first of S in the first rule gives only ABD symbols. Now if you apply the same rule on the other alternative, first of S is first of C. What is first of C here? First of C here is B. B is already there, so no need to add once again. Now because of epsilon, it continues with D. And what is D here? D is E. Now C derives to epsilon, D also. Both symbols, since they are deriving to epsilon, now and at the end only I will add epsilon. So though you have C here, it is not going with after B. Within B only it evaluates, not after this B. Here this C is used with B, not after this. Confident? Let's have one last example. Look at this example. Let's find out first of each of the non-terminals. Yes, A, B, C. Let us find out first of A's. First of A's is first of A. First of A is D here. And if you look at here, it is first of B. First of B is G here. Epsilon. So go back here. Hence first of C. First of C is H here. Now if you look at here, B derives epsilon, C derives epsilon. So B, C both derives epsilon. But you cannot add epsilon because this is because of this A. So continue with the next symbol C. Okay. Now it is first of C. First of C is what? H. H is already added. Okay. So go back here and because of epsilon continue with B. Now first of B is G. G is already added. Epsilon. Now look at this. A derives to epsilon through BC. C derives to epsilon. B also derives to epsilon. So remember this is where now you can add epsilon because evaluation of all the three is over and every non-terminal is ending with a epsilon. Hence now you can add epsilon. Here while evaluating A with BC you cannot add epsilon. You should go back and continue with the next symbol. So while applying first function on this is what the string of terminals we got. Now let's apply the rule for the next alternative C, D, B. So first of S is first of C. First of C is H. It is already there. Now epsilon, because of epsilon continues with B, hence add B. That's it. Since it is ending with a terminal, no need to continue further. That's it. Now coming to this, first of S is first of B. First of B is G. G is already added. Because of epsilon, now it continues with the next symbol. Hence add next symbol. So now the total symbol is DGH epsilon BA. Now coming to first of A. First of A is D here. B is G. Because of epsilon C. So H. And since both derives, add epsilon. Both derives to epsilon, hence add epsilon. Now coming to B it is G comma epsilon. Coming to C it is H comma epsilon. This is the simplest function first. Now let us take the other function follow. Follow is also very simple if you follow. So let us try to understand.